Hi guys, this is Mrs. Maurer again from Downstairs Chemistry. Hey, so last time we talked about displacement and vectors in the worksheet assignment with that. This time we're going to talk about velocity and graphs. And so with your substitute, you should have been able to do the fill in the blank part of this of just going through the slides. So I'm just going to show you the slides really quick to make sure that you are able to get through them. It starts with Introduction in Kinematics. And this particular lecture starts on slide 29. So I actually tried to put them all together. They're all together in one unit. So the first thing you need to remember is that change of time, delta t, is the final time minus the initial time. So just it's the exact same thing as the change of the equation, similar to displacement. Most of the time, the initial time is 0. So remember that change in time would just be the actual final time that you measured, which is great. You should have been able to get these two equations. This is the velocity equation, and this is the equation of position from velocity, and realize that a lot of times when we graph things, they change. And so in this particular place on your worksheet, you should have been able to see that if you draw a tangent line, which is also present right here, you calculate the slope of the line, and that will give you the information that you need. So example right here, it says if the graph is not a straight line, then use the slope of a tangent line drawn to that point. Here the graph is not a straight line, then draw the slope of the line to the tangent point. So you should be able to write in those equations and fill in the blanks on those. If you come down here to this graph, this is something that should have been drawn from looking at your notes from the PowerPoint. You've got the equation right here and the problem. They wrote down all the steps that you need to. So this is simply copying down the steps. And you want to draw the line tangent. And so you would come over here in your graph, draw the tangent line in this area. And you would also be checking these values. This is important. Your homework assignment is actually going to ask you to look at the graph and get the data points that you need to solve the problems. This next slide right here is this bottom slide right here. I think this is something that's a topic that's appropriate for AP, but I don't think it's good for general students. So I just want you to draw a big X to that page on your worksheet in case you're really wanting to know the answers. Question A says, sketch the graph of velocity versus time corresponding to the graph of displacement versus time given in the graph. So for AP students, you just use the technique find the slopes by drawing tangent lines. Sketch the graph based on those values. Number B says identify the times and values which time of A, time of B, time of C, etc. Which instantaneous velocity is the greatest. In this place it is D. You've got the greatest tangent slope. If you draw that line in here, you'll see a really, really fast tangent slope. And that's why that one is where that is. The rest of these it's growing, but their tangential lines aren't as steep. So they don't have as great a slope. C at which spot is time 0, so it is C, E, G, and L. So really you're looking at the apex of your movement. And D at which place is time negative, and that is point A, B, and F, and you can tell that because you've got a downward facing slope if you draw that line tangent. So that's how you would do that one. Again, general physics, I don't expect you guys to know that. But it might be something useful for the AP test, for my AP students. So you should have been able to also get this next example problem with the spine-tailed swift also copied directly from the notes. So let's go ahead and look at these homework questions and get some answers for you, help you get going solving some of those problems. Alright guys, so let's look at some of those homework problems. On this particular worksheet, I want you to skip problems 8, 9, and 11. I think you can do them. I think they're pretty good problems, but they're really, really rather complicated calculations in my opinion. You're going to have to use scientific notation to get the answer, so I think the numbers are a little bit too big. Go ahead and try them if you want to. If you look, the answers are already given to you, which is really, really nice. But you can see that you require scientific notation in order to get them. So I didn't think it was necessary to multiply exponents at this time. So you can skip 8, 9, and 11 because we are looking at some pretty big numbers. And I just want you to get used to some of the simple equations that we have. So for simplicity, again, if you want to be on the physics email list, you want to copy this video, go ahead and put in this Google Forms and go ahead and sign up and send me your email. Last class was on displacement. The YouTube link is right here on the board too. So you can pause the video, write those down. I can write them down on the board too so you can copy those. So simply from the lecture, from the study guide notes that you should see right here, velocity is the change of distance divided by the change in time. That's really important to learn it that way because when you look in calculus, there's actually different calculus equations that help us out. Often the position from velocity is actually right here. X equals velocity times time plus the initial velocity. In most circumstances, we also have to take into account acceleration too. But to simplify things, and because we haven't learned about acceleration, we'll learn about that next class, we're just going to use this simple equation. So I'm just going to erase those right here because we're going to assume that we're under a constant acceleration or that acceleration is no longer present. So let's look at those homework problems. Number 1 says, what is the meaning of obtaining a negative velocity? It means that we're slowing down. Okay, so you should have been able to get that one from the slides. That's a review one. Number 2, draw a quick sketch of position time graph of a ball being thrown up so it goes up and comes back down. So simply speaking, you're going to draw a parabola. Okay, so you should know that from your math classes. And so let's go ahead and look at problem number 3. Let me get the right cursor up here. Okay, so problem number 3, you actually need this graph to solve it. Problem 3 is kind of interesting. You're actually going to get your numbers from your calculations from this first graph over here that I just put in blue. Okay, so number 3 says a bus makes a trip according to the position time graph shown in the drawing. What is the average velocity, magnitude, and direction, so it's a vector, of the bus during each of the segments labeled A, B, and C? Express your answers in kilometers per hour. I have given the answer, so I just want to make sure that you get the process correct. Okay, so let's do segment A together. Alright, so number 3, we're going to look at A. A says we're looking at segment A of our graph. Okay, the first thing is simply going to be calculating displacement. So it's just like the displacement calculation last time, and it asks us what is the average velocity, magnitude, and direction of the bus during each of the segments. So segment A, the position that we have, final position, is at plus 10. So we're going to write plus 10, subtract 40. Okay, so we're going to get negative 10 minus 40. And then we're going to divide that by our time down here at the bottom of our graph. And our times are down here, so we've got 1.5, subtract 0. And if we go through and type that into our calculator, you will see that we actually get the numbers negative 20 kilometers per hour. Okay, so don't forget to write down their units. That's really, really important. Now let's go ahead and look at problem or segment of the graph B. And segment of the graph B is down here. So we're going to follow the exact same process. So you can see I've got delta V ready for us up on the board. And we need to look at the final distance. The final distance is over here at plus 20. So we're going to write down it is 20 minus its initial position, which is right here also, 10, divided by our time stamps also. Our final time is 2.5 minus 1.5. And that's kind of nice. So that is actually the number 1, which really helps us out. And so when we go through and get that solved, you can see that we've got the correct answer right here. We've got 10 kilometers per hour, which is pretty cool. Okay, so let's go ahead and look at C together. So here we've got C over here, and our final position is up here at 40 kilometers. So we're going to start at our final position, subtract our initial position, which is over here at 20. So we're going to have 40 minus 20, divided by our time differences. And we're going to be over here at 3 seconds. and go back to 2.5 seconds. So we're going to have the quantity 3 minus 2.5. That's going to give us the answer of a half. So we're going to take 40 minus 20, which will give us 20 divided by 0.5, and that will give us the answer that we see on our slide, which is 40 kilometers per hour. Okay, so it should be pretty simple and pretty straightforward. Problem number 4 is doing the exact same thing, and you are using this chart right here to answer those. So just make sure that you are getting your data points off of the chart, and it will really, really help you. Number 5 is asking what is the difference between speed and velocity. Remember, speed is something that you would measure on your odometer, so that would be something that your car would tell you, like miles per hour, but your car can't tell you the direction you're going. Okay? Velocity actually is a vector, and it has a direction involved with it. So speed, scalar quantity, velocity, direction. And so just remember, if you're curious about vectors, think of Victor on Despicable Me. He's committing crimes with magnitude and direction. So I always thought that was pretty funny. Okay. A is just another thought. Number 6 is another thought question. Does a car's odometer measure distance or displacement? I think you can answer that one. Just look at your notes last time. It is. And does its speedometer measure speed or velocity? So does the speedometer tell us the direction you're going? Okay. So the rest of these you should be able to do on your own. If you need more help, just come downstairs and see me. I'd be happy to help you finish this homework assignment. Again, skip problems 8, 9, and 11 unless you are an AP or really want to do it and just really want to do multiplications with scientific notation and figure out how fast the Los Angeles fault in California is moving. So, all right, I'll see you guys. Have a good day.